When it comes to high-performance systems, speed isn't just an accident, it's very carefully engineered. Today, we're going to break down one of the most critical pieces of that design, caching. This is how you really supercharge a system.
You've all felt this, right? The snappy, instant response of a really well-built app versus the frustrating lag of another. That difference, it isn't just about faster servers. It's about a smarter architecture. So what's the big secret? What's that trick that separates the instant from the infuriating?
Well, the answer, more often than not, isn't about throwing more hardware at the problem. It's this clever, kind of hidden layer that's designed for one thing and one thing only: pure, unadulterated speed.
To really understand the solution, we first have to get a handle on the problem. And in pretty much any growing application, the main bottleneck, you could call it the slowest room in the house, is always the database. It's where all the important stuff lives, but man, getting to it can be slow.
Think about it like this. Your system might have millions of pieces of data, but your users, they're probably all trying to get to the same few popular things over and over again. You know, the latest viral video, the top-selling product, a celebrity's profile. All these repeated requests for that same hot data create this massive traffic jam right at the database's front door.
And hey, this isn't just a theory. As our source material, scaling a system from 0 to millions of users points out, performance takes a direct hit from this constant, repetitive work. The challenge for us as engineers is crystal clear. We have got to break this cycle.
So, to solve this, let's use a simple analogy that's going to make this whole concept click. Imagine a huge library, and we're going to focus on the librarian's secret weapon for speed. A special little shelf right there behind the front desk.
This really captures the idea perfectly. The database, that's like the giant warehouse in the back. It has absolutely everything, but every single request means a long, slow trip. The cache, though, that's the small shelf right behind the desk. It only holds the most popular stuff, but getting it is instantaneous.
So that secret shelf has a technical name, a cache. And the most important word here is in-memory. See, unlike a database that stores data on a slower disk, a cache keeps it in super fast RAM. That is the source of its incredible speed. It's literally the digital version of having the book right at your fingertips instead of having to go find it in a warehouse.
Okay, so how does this actually work in the real world? Well, every time your application needs data, it all boils down to one of two simple outcomes: a cache hit, which is fantastic, or a cache miss, which is, well, it's a learning opportunity. Let's look at both.
First up, the ideal scenario, the fast path we are designing for, the glorious cache hit.
The flow is just beautifully simple. A user asks for some data. The application, just like our smart librarian, doesn't just run off to the warehouse. Nope, it first checks that fast front desk shelf, the cache. And boom, the data is right there. We call that a cache hit. The data is returned in a flash, and the database, it never even knew anything was happening.
But what happens when the book isn't on that special shelf? Well, that's what we call a cache miss. It's the slower path, for sure, but it's absolutely essential for how the system learns and gets faster.
So here, the request comes in, the application checks the cache, but it's empty. That's a cache miss. Now the application has to take that long walk to the database warehouse to get the data. But, and listen, this is the most important part. On the way back, it puts a copy of that data in the cache. This is how the system gets smarter over time. The first request might be slow, yeah, but every single request after that for the same data is going to be a super fast cache hit.
Of course, just having a cache isn't quite enough. I mean, a messy, outdated shelf is pretty much useless. To make this system really robust, we need a set of smart rules to manage it all effectively. So there are 4 key things to think about. First, an expiration policy. What if the info in a book becomes outdated? Well, we put a timer, a best before date, on the data so we don't serve stale info. Second, consistency. If someone updates the main copy back in the warehouse, we need a way to update the copy on our shelf. Third, an eviction policy. Our little shelf is small. It's going to get full. When we need to add a new book, which one do we kick out? A common way to do this is to remove the least recently used one. And finally, failure mitigation. What if the shelf breaks? We build in redundancy, maybe have multiple cache servers, so the whole library doesn't just grind to a halt.
When you put all of this together, caching isn't just some small optimization, it's a genuine superpower. It fundamentally changes the performance and the entire architecture of a modern application.
And we are not talking about a little improvement here. Accessing data from memory is orders of magnitude faster than getting it from a disk. We're talking more than 100 times faster. This is the difference between an action feeling totally instantaneous versus having that noticeable, frustrating delay.
So let's just wrap up with the key benefits. Caching really delivers this perfect trifecta of advantages. First, it creates a dramatically better, faster experience for your users. Second, it acts like a protective shield for your database, soaking up all those repetitive requests. And third, because of this, it reduces the load on the database, which is often the most expensive and difficult part of your system to scale.
So now you know the secret. You're in on the engineering behind so many of the fast applications you use every day. It's not magic, it's just well-managed cache. And that leads to a final thought. Once you start looking for them, you'll realize the performance bottlenecks are everywhere. So the question is, what other bottlenecks are hiding in plain sight, just waiting for their own clever solution?